In this tutorial, we're going to do a case study. We're going to build a BlackJack application, and we're going to cover a few different topics in building such an application. One is called unit testing. So I encourage you as you go through this to go and type in the code, the same code that we have here. So you may need to pause this several times. It's really important that you actually build this application and test it yourself and go through this process. It really does make a big difference in how you learn how all these modules will work together. So this is going to be an example of creating a complicated or a more complicated application like BlackJack from building it with modules that you have really completed in previous assignments. So first of all, we're going to look, you may or may not be familiar with the BlackJack application, so we'll quickly go over the BlackJack rules. Well, obviously it's a card game, and you have the cards from 2 to 9, and anything above that Jack, and they have these values, 2 points to 9 points. Jack, Queen, King all have 10 points, and you have an ace, which could be 1 or it could be 11. And the idea is to get a series of cards which add up to 21. And if you can do it in 2 cards, like you see here, that's called BlackJack, and it doesn't need to be black. They could be red Jack and a red ace. You're playing against a house, so you're each getting 2 cards. So let's see. I'll give you an example of a few hands here. Let's suppose that the house dealt themselves a 7 of spades and an ace of hearts, and I'm dealt the 6 of spades and the 10 of spades. The first option is for me to take cards if I wish to get closer to 21, and there's no restrictions on me. I've got 16 points. If I take a card and let's suppose I get the 8 of clubs, I've gone over 21, and therefore I bust and the house is 1. Let's suppose there's another hand and the house has the 5 of diamonds and 7 of spades for 12 points. I get the 2 of spades, 8 of hearts, and I'm dealt the 9 of clubs. So I have 19 points. The house, the rules for the house is that they have to take cards if they don't have 16 or less. If they have 17 or more, they have to stand. So let's suppose the house gets an ace. Okay, well, if the ace is 11, right away they're over. So the ace counts 1 point, so they've got 6 and 7, 13. They have to take another card. Let's suppose they get a 5, so they now have 18 points. They're not allowed to take any more. They have to stop, and the player wins. So that's a brief introduction to BlackJack. You should look up the rules if you're not familiar with the game, and get ready because we're going to start our BlackJack application by building small modules. So get out your shell and follow along, create these modules, and more importantly, test these modules so you know how to do a unit testing as we go through. What's the first thing you need to do when you're playing any card game? And that is you need to make a deck. So our first module is going to be called Shuffle Deck. And we're going to take this statement right out here. But what I want you to do is to put in a number of statements here for your shuffle deck. So define this program. We've talked before about Unicode, and the Unicode characters are simply to display the spade, the heart, and so on. So these are the 4 Unicode characters for spades, hearts, clubs, and diamonds. And then our rank are going to be literals. They're going to be the numbers 2, 3, 10, Jack, and you can see we have Queen, King, Ace. So I should make sure I give you the whole program here that you can see. So how's this program going to work? Well, we basically have defined suits as being the spades, clubs, hearts, and diamonds. And we've got a list for ranks that go from 2 to ace. And we've created a new deck. So our deck is obviously going to be a list. Now, to create that list, we've got two nested for loops. You should be familiar with that. So for every suit in suit, so this is suit, so the very first time through, this is what is going to be contained in suit. So it will be a literal that will print a spade. For rank and rank, so we're going to go through, in our inner loop, we're going to go through and iterate through this list. Our deck is an empty list. The very first time through, we're going to put the rank and the suit together. So since our rank might be spades, we're going to have a spade. The suit is the spade. The rank is going to be one of these. We'll have like two of spades. Now this is going to iterate, and what we're going to do is next time we're going to append rank is going to be the next character, 3 of spades, 4 of spades. So what we're doing is we're adding cards to our deck, starting with 2 of spades, 3 of spades, all the way up to ace of spades, and we're coming to the outside. We're getting a new suit here. I'm not sure which one this is. Maybe it's the diamonds, and we're going to add 2 of diamonds to the ace of diamonds in. We're going to do this 4 times and build a deck. So the unit test of this becomes after we create our program, it is so important to test it to see if it works. So let's do that. I'm going to make this a little smaller. So make sure you've got this program in, and then we'll do a unit test on it. So we're going to compile this, make sure we have no errors. And you'll notice that Shuffle Deck returns a list which is called deck. So I'm going to call this my deck equals Shuffle Deck. Boom. Now I need to look at my deck to make sure it's got 52 cards and they're all appropriate. So I'll make this a little larger. And we can see here we've got a list, and we have 2 of spades, but it's not in order, so it's a little more difficult to tell if this worked. Let's see what we can do about that. Now, looking at my output here, this is not quite what I expected. I expected my deck to get filled 2, 3, 4, and sort of go in order. And you may look at your code and say, I wonder why that is. I've made actually a little mistake here. I meant to create lists here, but notice I've got the curly braces. So what the curly braces have done is create sets instead of lists. So although I've defined the ranks this way, when I create a set internally, it's not stored in order. These could get stored in any order. So I put a little statement here, print rank and suit, and found out that, gee, it wasn't, these weren't in order 2, 3, 4, 5, and they were in some fairly weird order. And that's not a bad thing because I'd still get my deck, but I like to have something a little more ordered that I understand. So we're going to make these lists. And now I'll print my deck. And what I can see here is I have the spades, I have 2 of hearts to the ace of hearts, 2 of diamonds, ace of diamonds, and 2 of clubs to the ace of clubs. So I have my deck as I expect. The next thing we want to do is I want to return a shuffle deck because I'm just going to pick the top card out of the deck and deal it to someone. So I want to have simulated a shuffle deck, and we do that using the random statement, random.shuffle. We learned that in the last section. So I've created my suits, created my ranks, deck is my empty deck, and I've created my deck here. We're now going to shuffle the deck using random the shuffle method that can be used once we import. However, we need to import random. Or else shuffle won't be available to us. So let's try this once last time. And this time we should get that the deck is completely random or shuffled. So now what we've done is we've done some unit testing. We've got a module that will give us a deck. So let's look at the next element we might want to create here. Well, the next thing we might want to do is we might want to deal a card to a user. So what's involved in dealing a card? Well, I want to create a definition of a function, and I could call it deal. Obviously, we need to pass it a deck because we want to deal from the deck. So we've got our deck here. And the card that I'm going to return needs to go into someone's hand. So I don't want to just return a card. I want to also add it to a player's hand. So I'm going to pass a second argument here, and I'm just going to call that player. So that's going to be sort of my definition. What I need to do is I need to get the top card from the deck. So what I'm doing here is I'm writing sort of a pseudocode for the program that I want to write. And then I want to add this to the player hand. Okay, so I sort of got an idea in my mind now what I want to do. I'm now going to commit that to code. So through some magic, here's my program. By getting the top card, what pop does is it returns into card the last card from the deck, and it takes it out of the deck, which is simply a list of 52 strings. So now I'll have 51 strings. Player is a list that I'm going to append card to. So the very first time through, player will be a null string, and the first time I call deal card, it will add to that player list a card. So let's again do some unit testing to make sure this works. So I need to create a shuffle deck, which I've done. I'm going to create for myself just an empty list. So Dave has nothing. This is going to contain my cards. I'm now going to deal a card using my deck to myself. I'm going to pass it Dave. Now that's going to return the card which was dealt, but if I look at Dave, Dave should contain that card. If I did this again, and maybe again, we'll find that Dave contains a list of 3 cards. So each time I do this, it adds a card to my hand and it removes them from my deck. So if I looked at the length of my deck, I would see now it's 49 from 52. So I've done unit testing on this to make sure this module completely works before I integrate it into something else. Next, we're going to develop a function called total that takes a blackjack hand and uses the best assignment of aces, remember aces can be 1s or 11s, to return the best possible value for the hand. And it makes sense to do this in a modular function because it's somewhat complex, so I want to sort of encapsulate it in just this function. Try to get the function working, debugging. Maybe you have a separate person who's writing this type of module. So let's look at, again, the pencil and paper method of trying to come up with a method for doing this. Well, we're going to take, basically the suit is not important, but the rank is important. And the rank are simple strings like 2 or K for king. How do we turn those into values? The 2 for a value, well, 2 to 9 would be easy, but king, queen, those would not be as easy. So let's use something we've learned called a dictionary. So for the dictionary key, we're going to use these strings, and the values are going to be from 2 to 9, and the value for a jack, a king, those values are all going to be 10, and the ace is going to have a value of 11 for now. So one of the first tasks is to use a dictionary to get the values of cards. So we'll create that dictionary as one of the first things in our function. Now we may have a hand that is similar to this, 2 of hearts. 8, I'll just put C for clubs, 10 of spades. So how do we add this all up? Well, we're going to do something, we're going to use a for loop to iterate across our hand. And for each card, each of these are individual assignments. So for each card in the hand, add up the values. We're also going to find out, add up the number of aces that we have, because aces are special. So aces could be either 1 or 11. We're giving them a value of 11 up here in our dictionary, but we may want to reduce that to 1. So if we add everything up, and if our result is greater than 21, and if I have aces, so if I have some aces in here, what I want to do is I want to change the aces from 11 to 1. So that's sort of an outline of what I want to do to add up and value my hand. Now you could actually, so this is a bit of pseudocode. You could actually work this out with a flow chart. If you were truly writing this from scratch, you would get more detail here and make sure that you really have the logic for this nailed down more tightly before committing to code. But the point is here is we do not write code right away. We do this on pencil and paper and try to figure out some approach. Now we're going to look at our program that can do this for us. And of course, then we're going to test it fully. And so you can pause this to type this in. Some quick explanation is we've created our dictionary here called values, and you'll notice it has the keys are the ranks of the cards all the way up to ace. We've started some accumulators here that we're going to use to accumulate values, result in number of aces. Now, let's suppose I've got a hand that's got 3 of clubs and 4 of spades and ace of hearts and so on. So if that's my hand, for card in hand, the very first time through card is going to be this. So the result, what we're going to do here is we're going to accumulate into result values, which is my dictionary, of card 0. So card 0 means we're going to pick off that first digit which is a string 3. We're going to go to values, our dictionary, and say, okay, I'm going to match the string 3, and it's going to return the value that's there, which is a 3, and that's going to get added to result. So this statement does result equals result plus 3. It's going to do this for every card in my hand. Second time, it's going to get the 4. It's going to add, it's going to get 7. Third time through, it's going to pick off the A. It's going to go here. It's going to see that, but the result is going to be 11. So it's going to add that to result. So result, in this case, would be 18. Let's just suppose we had one more card, like a 5 of something, clubs. This would iterate once more. We would add 5 and we would get 23. Now, because this is indented at the same level, this if statement is also done. If one of the cards was an ace, the number of aces is incremented by 1. And I have an ace in my hand here, so this gets totaled. So this little loop adds up all my points, and it adds up how many aces I have in my hand. When it's done, here's what we have. It now drops down to here and says while. So we do this while my result is greater than 21, and I have aces that I've accounted for. So here's what we're going to do. We've basically busted. We're over 21 here, but we have an ace. So let's use the ace as a 1. So to use the ace as a 1, I basically reduce this by 10, subtract 10 from it, and I get 13. So my result comes to 13. My number of aces gets decremented, so now I've used up all my aces. Now that's my total that I have in my hand. And if I use the ace as a 1, is that right? Well, 5 and 1 is 6, 10, 13. That's right. And then we return what's in our result, which is the total of the hand. And this little loop will work for multiple aces if we have it. So we now have something that we've gone through that seems to work. We now need to do the unit testing of this to really make sure it works. And what we need to do are pass it hands. And so let's do our unit testing. Now, for unit testing, we don't need to go through the deck and all kinds of other things. We simply need to look at this as a bit of a black box. What are we passing it? Okay, so I'm going to make up a few hands here. Now, what's really important is the first character. That's all I'm striking out. So I can just use a C for clubs, or I can just use an X. It really doesn't matter what's here. I'm creating in the hand is a list of cards. So I've got a 3 card. Let's suppose I've got a 5 card. And let's suppose I'm going to use a Jack, which is a capital J. And it's important to use capital J because my dictionary uses a capital. So we'll just basically do a unit test here. And I forgot my quote. For a simple hand. And now I'll call total hand and it return 18. And we'll see if that works. Yep, that seems to be good. Hand equals, and now we'll do let's just add, probably the easiest way is to just do this. Now let's make sure aces thing works. So we'll add a couple aces in here. Redefine hand. And we get 20, which it does work. Now you would normally do a few more tests. You're trying now, because you've written the program, you should know the weaknesses of it. So if there are any values that are special, you can see if they do those as tests to see if they cause any issues with your program. But we didn't need to involve the shuffle deck or the deal card to test this module. We just needed to create some input that would test this. So that was our unit test for this program. Next, we're going to look at a function that compares the hands and finds out who wins, the house or the player. So we dig out our pencil and paper again, and we look at our rules of blackjack, and basically if the house has more points than the player, then the house wins. If they're equal, well, it could be a tie, but and if the house is less than the player, then the player is going to win. Now, it's possible that both the house and the player could get 21. Now, whoever gets it with a blackjack will win. If someone's gotten 21 from 2 10s and an ace, that's not considered a blackjack. And so although they both have 21, the blackjack will win. So now we need to test to see, does house have 21 and blackjack and player doesn't? No blackjack, because then the house wins. And we would need to test the other. The reverse of that is, does the player have 21? The house may have 21, but if the house doesn't have 21 in 2 cards, then the player would win. And finally, if we've tested all this doesn't happen, then it's a tie and there's no winner. So we've worked out very quickly here on a piece of paper, but we would normally draw this as a flow chart and then commit to code, or do it in what's called pseudocode, something a little more detailed than I've done here. So let's look at our next function. So we've created our function called compare hands. We're going to pass to it 2 hands, which is a list of a number of cards. So the hands might be, oops. So this would just be a list of something like 2 of hearts, something like this, 10 of clubs, and maybe a 6 of spades. And the player would also be a list of cards. And we would pass them through this function that we've already created called total to get a house total and a player total. Now we're going to compare them. If the house is greater than the player, then I lose. If the house is less than the player total, the player wins. Now we've got something that may be a little hard to understand here, but remember what we're having is multiple comparisons. So this is looking for, really this is doing this. Remember how Python expands these multiple comparisons. So, does the house have 21? And does it have 21 with 2 cards, and the length of the house is less than the length of the player has more than 2 cards? So here we have a blackjack for the house. The player does not have blackjack and 2 cards, therefore I lose. Now this is just the opposite. We're doing the same test, but we're saying the player has 21 and the player has a length of 2, meaning the player has a blackjack, the house doesn't, then I win. Otherwise it's a tie. So we'll just show one test, but you should do a number of tests to make sure your logic is working. Now I happen to know this logic works because I've done tests on this before. What I've done is I've compiled this, I've put it in memory. I've created two hands here, and again, remember, we don't need to have anything here. You create your own test cases with as minimal data as you need to make it work. And we're going to compare, run the compare hands, and we're going to pass it the H, which is the house. It has 17, the player has 19, so we would expect this to print the player wins. You win. And you would do this for a number of different test cases very quickly. I could do this, just exchange the two hands, and I could do this again, then I lose. But you would do a number of hands to make sure you test all your logic here. Now, to put this all together, finally we need to write our BlackJack main program. So what's this going to do? Well, the first thing it's going to do, it's going to shuffle the deck, create a deck of shuffled cards. We're then going to deal or create two cards to both the house and the player. And we're going to print the hands out. We then need to ask player, if they want to hit or stand, which means we would pass. And if they hit, we want to deal a card. If no, that is if they want to stand, we want to move on. So we're just going to loop here and let the until the player no longer wants to hit. Then the house hits itself until it's got 17 or more, and then it has to stand. And finally, we want to compare hands and find the winner. So we work this out in our head, we look at all the functions that we have, and now we start to commit these functions into a program. But what have we done? We've created 4 modules already. We've tested each module, we've broken it down, we've applied unit testing, so we're fairly confident each of these things are going to work, and now we're writing the final program. Now, the final program looks like this. And you'll need to type some of it in, pause it, and type the rest of it in. You won't be able to see it all in one screenshot, I don't think, here. So let's see how much we see. So here's the first half. This is the main program, so we would just call BlackJack. It's going to get a deck from using the shuffle deck. We're going to create empty lists for the house and the player. We're not building them yet. We're going to do a little for loop just twice because we're only dealing 2 cards, and we're going to deal a card to the player list and deal a card to the house list, and we're just doing this loop twice, 0 to 1. We're now going to just print the hand so you can see and give some feedback to the user. Now, we're going to have some input. Hit or stand. So this is the player. Wall the answer in. So what this does is this means if the user doesn't type anything, if they just hit enter, they'll get a null string. Or if they just type an H for hit, or if they type the letters HIT, in those three cases, we'll deal the player a card. And then we'll print that card. Now we've got to check to see if we make sure the total, we'll use our total function, is greater than 21. If it is, you'll bust and you're actually going to print, oops, sorry, you've lost. And we're going to return right away because the game ends. But if not, we go back up and ask them again, do you want to hit or stay? And if they type anything other than enter H or hit, we end our while loop and we go down here. Now this is the turn for the house. So we do a total to find out how much the house has. If it's less than 17, the house has to take a card. So we deal a card to the house and we print it. If the house total is greater than 21, the house busts. So the house busts, you lose, again, you return right away. But if the house doesn't bust, this is a while loop, we go up and test. Is the house total less than 17? If it's not, it's greater than 17, then we go down here. At this point, when we arrive here, the player has a hand that's less than 21 and the house has a hand that's less than 21. So we compare the hands and determine the winner. Okay, we've got our blackjack game all finished. We've tested each module. We now need to test the overall blackjack program to see how well it works. We've compiled it. There are no errors. So here we go. The house has 15. I've got 9. So if I hit enter, I'll get another card. I've got 13. I think I'll take another. I've got 18. So I'm going to stand. I'll hit S for stand. The house got a 9. The house busts. So I win. Let's try another game. Whoops. I now have 19, so I'm going to stand. The house has 12. The house got a jack. It busts again, and you win. And you can continue testing this. So we've written a blackjack program by breaking down a complicated program into small individual modules. We've then applied what's called unit testing to test each module to make sure each one works. And really it's very important to test it. I've worked in teams, software teams, where people have written software and have never tested it. Then when it comes to integrate into this program, you have no end of debugging to do because various modules were never tested properly, and so you have all kinds of bugs in these modules. But if you do proper unit testing and all your modules work, this can be a very efficient process in writing a program which on the outside looks very complicated, but as you break it down to simpler problems and simpler modules, you can put this together pretty quickly and very successfully.